One of the first questions you might come up with is, what are software requirements? Why do we care about them? I mean, if I'm sit down with a problem, I can just go code that, right? I mean, I've been doing that in class for a while now. Well, maybe, but fundamentally, we don't always know what software developers are supposed to build. Somebody has to go through and figure out who really wants this and what really value is it adding, etc. We need to make sure we're building the right thing, essentially. So we can do that in a ton of different ways. There's so many different methodologies, and we're going to talk about them as we go. But generally speaking, we want to formally write down these are the people we care about. This is what they want. Maybe even a little why they want it. And then write it down in such a way that we can lead into building the right bit of software. Now, why do we bother with that though? I mean, it's all nice and good. Why do I get formal with it? Why don't I just, you know, have a conversation, take some notes on a napkin, and run from there? Well, sometimes we do it for contractual reasons. If somebody's paying us to build software, and I'm a software developer, and you're a person who does banking, defense contracting, airline reservations, things like we're asked to do in the class, you might not want to hire me full time. You might not want me to be on your payroll full time. You just want to have me around, build your software, let me go away. I might not work for you full time, but we still have to have some way of knowing, did I build what you want? And then did you get what you asked for? That sort of thing. So there might be a contractual reason we want to do formal requirements. But even without that, let's say I do work for the bank. Let's say I do work for the airlines. I do work for a defense contractor, though requirements are huge there because the government doesn't normally build their own stuff. Part of that is follow through. So we had an intent up front. We do some design, we do build some code. 3, 6, 9 months, a year later, we hand it over to a testing group. How do they know what we plan to do to begin with? How do they know what was really the intent of the features? How do I know that what I got was what I intended to build? And requirements is one way to do that. It gives us a milestone by which we can track things all the way through. So where do these things come from then? If they're occasionally arbitrary, we're not entirely sure. Well, there's a lot of different sorts of requirements. So we have, in some cases, we just go and figure out a need. Hey, in the bank, I need to deposit checks. It takes a really long time to type them in. Let's build a image system where I can scan it in and automatically read what somebody wrote on the check. Wouldn't that be great? That's a need. Not necessarily coming from a specific ask, but most of the time we do have things like customers who say, "Hey, wouldn't it be great if I could deposit this check remotely? I can take a picture with my cell phone, boom, have that check be deposited." Sometimes it's a contract. We say, "Hey, my bank wants to do business with this supermarket chain. In order to do business with the supermarket chain, we need to accommodate something, something, something." That's some contract that some business need that's out there that I build software for that reason. And sometimes it's laws. I've been working in healthcare the last couple of years, and contracts and laws is the vast majority of the software we build. When the Affordable Care Act came out, tons and tons of work for us to do. When they said there's religious exceptions, tons and tons of work for us to do. Every time they change a law, my job employment goes up and up and up. So there's all sorts of drivers for software requirements, some of which is really not even an external driver. Sometimes there's big projects where I have these systems that get designed. Defense contracting is a great example of this, where I'm going to build a joint strike fighter, and it's going to have a bunch of systems. There's going to be engines, and there's going to be avionics, and there's going to be missiles, and there's going to be radar, and there's going to be all these different pieces. And software sometimes is driven based off of other decisions. We have them trickle down to our stuff. Sometimes it's driven by existing components. Let's go a different direction. So we're doing a project where in healthcare where we're integrating with a debit card. So you can run your debit card, swipe the debit card. Some of our requirements are driven by the way that stuff is implemented. It might not behave the way we want it to, but we have to do it that way because that's the way it's already built. We have already selected a solution here and we go build around it in that way. So requirements, there's not a fixed place, but there's a lot of tricky things that are coming up. And understanding where they come from is important because you have to understand, is it a requirement or is it a reality of the current situation? Sometimes you'll say, like, I mean, there's lots of examples of it. You might have heard the story of a young lady asked her mom why she always cut the ends off of a ham every time they baked the ham. there's some that she said, well, it tastes better that way when you cut the ends off. It's like, well, that doesn't make sense. Why didn't everybody cut the ends off the ham? Why would the ham cut with its ends cut off? And so she went and asked Grandma, why did you cut the ends off the ham? And she's like, I don't know. My mother always did it that way. Then she goes and got to great grandma. Why did you cut the ends off the ham? Well, I had a small oven when I was cooking it. The whole ham wouldn't fit in, so I cut the ends off and cooked it so it would fit in. Again, was it a requirement to cut the ends off the ham? Well, at the time it was because it was a small oven. Down the line, 3 generations, you got big ovens. You don't need to cut the ends off the ham. That's the sort of thing. That's why we want to know, where do they come from? Why have we decided to build the system the way we decided to build the system? And so let's talk a little bit about where requirements do come from the standpoint of stakeholders. There's a lot of different stakeholders. Anybody who's a part of the project is technically a stakeholder. But the ones we get requirements from, starting with, is generally the users and the people we're buying it from. Maybe the auditors or the legal aspects or things like that. But they're the people who say, what do we really need? And then apply constraints on that. So yeah, what do I want? Well, I want a phone app that does this, this, and this. Well, does it have to be a phone app? That's what we want to talk about as a stakeholder. We want to understand. Well, do you think it needs to be a phone app? Why do you think it needs to be a phone app? Because sometimes they'll have a phone app because I have an iPhone. I want an app that goes to my phone. Well, can we do that with a HTML5 web page that somebody can pull up? No, I want an app. Okay. Well, the requirements to have an app, but we write down we want to have an app because Big Boss said so. So we want to understand the stakeholders. We want to come there coming where they're coming from. We have internal stakeholders as well. Sometimes we have additional requirements based off of the needs of managing the systems. So the users can go through and reset their own passwords using prompts for secret questions. What's your mother's maiden name? That sort of stuff. Well, what happens if they forget those? Well, that means they have to call into customer service and reset their password through a manual verification. Okay, well, what's the screens look like for that? Oh, we didn't put those in there. Well, there's a requirement. It's not a user requirement. The user can't do it, but we have internal needs for that sort of stuff. So we want to understand, who are all the stakeholders. Sometimes system administration, people who never deal with the system at all, needs to be a stakeholder, because if they have data that needs to be encrypted, they have to have requirements by which, how is that data going to be encrypted? How are we going to manage that? And so primarily when we think of stakeholders, we think of external stakeholders, the customers, the users, the regulators, the legal, the general public. What do you mean general public? Well, if you have a system that keeps track of all the purchases done at a major retailer, like say Target, if you ever shop at Target, you certainly want to know your credit card data was protected. You certainly want to know that terminal can't have viruses put into it that steals your credit card data along the way. You don't work for Target, but you still care about being Target. Well, let's go beyond that. Let's say you live in town and you like to use electricity, like so many of us do. Don't you want that power plant to have certain security measures? Don't you have that power plant have certain reliability measures, certain requirements that are there that makes the electricity not stop working? So there's general public can be impacted in interesting ways. Let's say you breathe air. You certainly want Volvo not to have, I think it was Volvo, but not to have cars that cheat on the emissions test. There's been, some huge number of people who've been thought to have gotten sick because of the lead coming out of tailpipes. You don't get to choose whether or not you breathe air. It's there, but you could be affected by software requirements. So you need to understand that. Internal project, we have the people who write the requirements, the analysts, people who code it, the administrators, like we talked about, testers, even the management have stakes in it. The trick here is not to ignore any of these roles. It's to weigh the roles appropriately. Any one role shouldn't say, I want it this way and it shall be done, outside of maybe the people paying for it. But even then, you want to have conversations. You want to go through, you want to document this information. You want to know where it's coming from and why. So as we go to capture the requirements, we have a bunch of general steps we want to consider here. We want to recognize what the problem really is. We talked about that a little bit. We'll go into that a little bit more detail in a second. We want to go and evaluate, what are the options? What are the different things? What do we really need to write down? Do some synthesis to be able to pull together all this stuff and figure out what's going on. We don't just start writing everything down and go from there. We want to have some kind of clever approach to that. We can enhance that through modeling. Knowing what we want the system to do isn't so bad. Knowing all of what we want the system to do can be difficult. And modeling can help us get through that. And when we talk about specification, that's where we're going to get formal about it. We're going to actually write this stuff down. And wait a minute, I thought we were always doing requirements. Well, it's like anything. When you start writing a paper, do you really start writing the paper from day one? No, you write some notes, you do some research, you write some more notes, you do some graphs, you do some charts, you do some planning, you make an outline, and then you write it all down. Same sort of thing here. And then obviously the review cycle to finish it up. So let's walk through this a little bit. Problem recognition is really key. Let's understand what the problem is. Um, I'm working on a project now. And I have a problem that came to us. The business said, we need you to do this, this, and this. I'm not going to go into too much detail. And so the requirement said we need you to do this, this, and this. And when we started looking at the system, doing this, this, and this was really challenging. Our system was not built to do this, this, and this, especially in the order this, this, and then this. Again, I know it's a little bit vague. The point being, the real need out there was we need the system to do what's a mode Bobby. And this, and this was one way to do what's a mode Bobby, but there was lots of other ways to do it as well. So we kind of came up with, well, the really need is we want to be able to pay for stuff. Okay, well, the old-fashioned way is one way to pay for stuff, but we can also do it this other way. And the other way saves us a ton of time in implementation. It gets the stuff delivered faster, cheaper, and actually is less confusing overall for everybody. Because instead of creating a new type of a special process, we're creating a new process altogether. So that's the type of thing we want to do with recognize the problem. We want development not to get stuck on the technology there. We want to think outside the box in the very cliche sort of way, but we want to come up with thoughts of how do we really meet this need without falling in love with the first idea that came to light there. And so part of the way we can do that is through a little bit of evaluation. We can go to the environment, we can look around. So this is not as common of a technique anymore because software is so ubiquitous. Most of what we do is we built every system ever and then we just kind of tweak it. That's the thought, at least. But sometimes it is useful. So think about it 30 years ago when the first software systems were built. I mean, nothing ever existed before. How do you know what rules to go implement? Well, if you think about, let's say, depositing a check. Well, what used to happen? I used to have a person who would receive the check and they would write down in a ledger that this person received this check of this number and everything else. And then that check would be forwarded on to a central processing house who somebody would write it down, and then forwarded on to the bank where the check came from where somebody would write it down, and then the bank would say, yep, this is the amount, and they give it to the bank, and they give it to the bank, and money is changed, back and forth behind the scenes. And that was all done with paper. There's people, there's dozens or hundreds or thousands of people who sat in little offices and read pieces of paper, and every single check that was written went through somebody's hand, and it was moved from bank to bank until it got paid for. That's essentially what happens today in the electronic automated clearinghouse, so it's called ACH. Um, they used to have physical clearinghouses where checks were mailed around the country, and then they had physical clearinghouses where checks were mailed around the country and then typed into computers. And now you can take a picture of your check, and your paper check never even has to move from one place to another, or you can just give them the numbers, and they do it all electronically. But we learned it by going to the environment. We learned it by watching what people do and writing down what they do and analyzing what they do. And in some cases, it was efficient. In some cases, not so much. Automated Clearinghouse really is this clever system, but not an electronic clever system. It takes days and days and days for checks to reconcile because when we created it, we didn't have the internet. We had, we had moved files, big files, but we didn't have real-time internet. It wasn't fast enough for that sort of stuff. So just understand, this is not a flawless technique. It's a way of understanding the system. But we want to go through with synthesis and see if we understand what's going on. Is there a way to improve it? Is there a way to go through it? So the key to being able to do that is being able to capture data. And how we capture data can be really tough. It could be sitting around watching people do their job. But that's not always an option, especially if the system never existed before. Nobody sat around and watched people write notes to each other and came up with Twitter. I don't think so, at least. There was some thought process that had to go into it, some creation. And so what they had to do was consider, what do we want? What do we want to get out of this? I mean, and Twitter's not a great example. They built it in like 2 weeks and just a bunch of people sitting around a room saying, this is what I want. It's exactly the opposite of what we're trying to get done here. But sometimes what we want to sit down with people and just say, hey, how do we do this? We're going to talk about this a little bit. We're going to talk about how we go through and capture that data. So I'm not going to go into it much more right here. With that data, though, we need to do something to capture it in a cohesive format. We need to take notes. And one of the great things we can do in software development is take notes in a very structured way called a model. A model helps us understand the system. It's a way of drawing pictures and capturing just specific information enough to be able to help us understand what do we need, what do we, what's essential to the system, and how does it structured, how is it related to other parts of the system. And so it's a great way to get a quick look at a process. Now, modeling is normally thought of as a diagram process. It doesn't have to be. There's other ways of making it happen. And there's a couple different methodologies. It started off with structured analysis, which is a very functional way to look at models, and then it's kind of moved into object-oriented analysis, which is more of a looking at the pieces and the artifacts. But what's important is what goes into the model. Traditionally speaking, a model is a scaled down version of the real thing. I'm not going to try and capture what every person does. I'm going to capture what a taste of that is. The scaling down doesn't really mean much in software development outside of the fact of the amount of information I capture, because software is the same thing no matter what size it is. I mean, it all fits on a disk. So what we really want to capture here is the key information. Let's cut through the whole bunch of information out there. Let's get to what information do I want? What data am I tracking here? What fields are people typing into machines or screens or writing on paper and I'm reading in? And then what behavior happens with that data? What's going on? How is that data changing? How is the system responding to different events that are happening inside of there? Both from straight, I clicked on something, and also stuff asynchronous that comes along. By looking at these pieces, it gives me a feel for what my system does as a whole and gives me a little better feel of what I want the system to do. And so now that I've gone through this whole process, I've considered the options, I've gathered some stuff, that's all the prelude work to get to the specification. And this is what we're going to build a little bit here. We'll spend a little bit of time talking about some of these activities we do, and then when we get into next week, we'll get into starting to write down some requirements. And so the data is going to be gathered. We're going to arrange the data, and we're going to write down in very formal contractual language what we want. Last stage is go back and double check it. We're going to take that document and give it to a group of people and say, is this, users, is this what you wanted? Developers, can you go off and build this? Testers, do you know how to test this stuff? Does it make sense from that standpoint? Whoever, focus groups, does this look like a great product to build? However you want to do that. I don't know there. But the idea is to go through and make sure you have the right information, that you've captured it in an accurate way, to make sure you haven't missed anything huge. Just basically to have the final, yep, this is what we want to do, sign off, and go from there. So one other note inside of here, as we're going through and looking at requirements capture and all that sort of approach, is we want to not just capture what we're going to do from the requirements, but try and capture where those requirements came from. Is there some previous implementation? Is there some previous documentation that's coming from? What's the history that gets to that? Because as I was mentioned before, sometimes we have some need that was there a long time ago that's not really a need anymore. There's a law that got repealed. There's a boss who doesn't work here anymore. There's a risk that didn't turn out to be realistic. We have this backup process because we were afraid that the disks wouldn't hold that much data, or the solid state was going to be a flaky technology. Well, it's fine. It's working. It's great. I mean, it's actually better than the other disks. So we don't need this backup process to run 4 times a day now. We can do it once a week. That's the type of thing we want to understand. Beyond that, consider actually starting to build this stuff while you're doing the requirements. Build a prototype of the user interfaces. It doesn't have to be functional. I worked for a company where we did requirements in 3 days. We had a meeting. We wrote some stuff up. 3 days. Well, we delivered them at the end of the week. So we had a meeting. Then we would write stuff up the next day, build up some screens the following day, and then ship that off for review. It was a huge project. It would take a week, but the whole idea was, instead of taking 6 months to go off and build requirements, we would try and get it done in a week. It was a consulting company. We were trying to be fancy. And part of that was we built out the screens. It was HTML where you clicked the button. It didn't actually do anything. It just took you to the next screen that looked like you did something. It didn't actually take the data you typed in and do anything with that data. It was all pre-canned data. It was all already filled in, moved along. But that allowed us to really see what the system would look like. So we want to be able to go off and take a look at it and not just deal with words and abstractions. And then we want to really understand beyond just what the requirements are, what's the priority of the requirements. Sometimes I can't get everything done in the time frame. So if upfront as you're writing it, you give a priority like, hey, this is absolutely essential. This is nice to have. This can come later on. I don't really care about this, but it might be nice. Then that'll give you a feel to help drive the priorities of how things get done. It allows you to be able to hand off those priorities, and especially if you're dealing with a contract, instead of somebody going off and telling you it's $1 million system to even get started, maybe you can say, okay, it's $100,000 to get started, but all the rest of the add-ons are another $900,000. So you just do, instead of just saying I'm not going to do the project, I could do it in a little bit different way. I do it a little bit at a time. All right, so that's hopefully giving you a feel for why we're here. From here, we want to go into some other, like, what do we do to flesh this out? That's what we're going to do in the future videos. So take a break, come back, and watch some of those videos.